So far, we have learned two ways to solve a system of two equations. One way was by graphing, and the other way was by substitution. This method is called the elimination method, or some books like to call it the addition method. Okay, so what we're doing is we're actually adding the two equations together, but we're eliminating a variable. So first I want you to notice which variable we're going to eliminate. We want to eliminate, that means we want to add them together to get 0, one of these variables. Okay, so if you think about it, if you added 2x plus 2x, that's not going to be 0. Okay, but what if I added negative 9y plus, 9y plus negative 9y? That will be 0. So what we're going to do is we're going to add these two equations together, and we're going to eliminate the y term, okay? Because 9y plus negative 9y, that's going to be 0y. So we have to add every like term together. So we're going to add 2x plus 2x. And again, we've already decided that the term, y term, is what we're going to eliminate by adding 9y plus negative 9y. And then we're going to add together the constant terms on the other side. So 4 plus 4 is 8. So we usually use the elimination method when both equations, are in standard form. Remember, standard form is ax plus by equals c. That is normally when we use the elimination method. All right, so now come back over here. We're going to solve for x, and we get x equals 2. So now we go back to, I usually go back to one of the original equations. I try to pick the one that to me is easiest. To me, the easiest one is the one that has all positives. Okay, so I'm going to take that equation number 1, and I'm going to take these 2 that I found the x to be and plug it into that equation. And so I get 4 plus 9y equals 4. Subtract 4 and divide by 9. So anytime you have 0 divided by a number, 0 is on top, then that is 0. So y equals 0 and x equals 2. And just like all the other ones, we're going to type it as an ordered pair. So 2, the x term first, and then the y term. Okay, so that is the easiest elimination type problem you're going to see. Okay, let's get another one that's easy. And again, it's easy because we already can see that we're going to be able to eliminate the y terms by adding these two equations together. Now, sometimes we're going to have to do something to them first, but these are easy. We're starting off easy. So we're going to add like terms together. So start with the x terms. That is 6x. Remember, this is going to be 0 because it zeroes out. It is eliminated. Now add 38 and negative 14, and we get 24. So x equals 4. All right, so we got x equals 4. Now I'm going to go to the top equation because that one is the one that looks easiest to me. It might have some big numbers, but doesn't have negative, so I'm gonna do that. It doesn't really matter. Okay, you can take either equation and plug it back in for x and solve for y. So subtract 16, 11y equals 22, and y equals 2. All right, so we're going to write our ordered pair. Okay, make sure you read the directions. Ordered pair 4, 2. All right, now look at one where we're going to eliminate the x terms. So this one, we're going to eliminate x because x and negative x will be 0. So it helps to determine what we're going to eliminate before we get started on adding these together. So we're going to eliminate those. That's 0x. Now let's add the y terms. So that's 2y equals. Now add the constant terms. So negative 8 plus 12 is 4. And we get y equals 2. Now, again, this one has negatives in both equations. It doesn't matter which one you pick. I'm going to pick the one where x is positive. So x minus 3y equals negative 8. Again, it does not matter which equation you choose. All right, so in this one, x equals negative 2. Now be careful when you type your solution. Make sure the number that stands for x comes first, then the number that stands for y. All right, so those were easy because we didn't have to do anything but just add them together. Now look at this one. If we were just kind of glancing at it, if we were to add the x's together, we'd get 4x. And if we were to add the y's together, we would not get 0. So we need one of them to be 0. All right, either the y or the x. Personally, at this point, what I want to do is I want to make this one a positive. Because negative 6 plus positive 6, that is 0. But in order to do that, I have to multiply the whole equation by negative 1. So the top equation is going to stay the same. And I'm going to multiply negative 1 times x, negative 1 times negative 6y, and negative 1 times negative 7. So why did I do that? Well, I did that so I can eliminate the y terms. Okay? To me, that was the easiest way to do that. And in order to eliminate the y terms, whatever I do to one term, I have to do to all of them. So that's why I had to multiply every single term by negative 1. So now I can eliminate the y terms. So add the 3x and the negative x. This is going to become 0. Then add the 3 and the 7. And now we can solve for x. All right, now I'm going to go back to, I'm going to just pick the first one. So, doesn't matter. Usually, it doesn't really matter. I usually pick the first one, but you can pick the bottom one if you want. So subtract 15. Get that a little bit better here with my numbers. And divide by negative 6. So y equals 2. Alright, so this one, the answer is 5, 2. Remember, whatever x is comes first, whatever y is comes second. Okay, on this one, alright, so I got 3x and x. And then I have 2y and 5y. Neither one of those will become 0 if I just were to add these together. So, which one would be easiest to eliminate? I feel like the x term would be easiest to eliminate if I multiply every term by negative 3. Okay, so keep the top equation the same and multiply every term by negative 3. That'd be negative 3x minus 15y equals negative 39. Now, again, why did I do that? Well, I want the x terms to be opposite. So if you haven't figured that out yet, I want the x terms or the y terms to be opposites. So that's why I'm making sure I can read that better. Okay, so that's why I multiplied the bottom equation by negative 3, so that when I add 3x and negative 3x, I get 0. Now I'm going to add 2y and negative 15y, and I get negative 13y. Sorry, OCD here. All right, negative 13y equals, now I'm going to add 13 and negative 39, and I get negative 26. And y equals 2. All right, so now I'm going to multiply. I'm just going to take let's do the bottom equation this time, just for fun. Now, I'm taking the original bottom equation, and I'm going to plug in y for 2. I mean, 2 for y. Put that backwards. So subtract 10, and x equals 3. So x equals 3, y equals 2. Write it as an ordered pair. Make sure that you write the x term first. So that's, whoa. Try that again. So x is 3, y is 2. Okay? All right. Let's see. Let's do one more of these, and then we will look at some other type. All right, so number 6. Now, notice that we have 2x and 5x. That's not going to be 0. We have negative 2y and positive 5y. That will not be 0. So I need to eliminate one of these variables. I'm going to pick the one that they're already different signs. So I'm going to eliminate the y terms. All right, so I want to multiply the top one by 5 and the bottom one by 2. Now, the reason why is when I multiply 5 times negative 2y, I get negative 10y, and 2 times positive 5y, I get positive 10y. So that will become 0. So I'm going to actually do both equations by a different number. Okay, so 5 times 2x, 5 times negative 2y, 5 times 8. And then we're going to do the bottom. 2 times 5x, 2 times positive 5y, and 2 times negative 10. So again, the reason why I did that was so I can eliminate one of the variables. I'm eliminating the y term. So I'm going to add the x's. Remember, this is going to be 0. And then negative 40, that's positive 40. Positive 40 and negative 20 will be positive 20. So x equals 1. All right, now take one of the equations. Let's just do the bottom one again just for fun. And plug in the 1 for x and solve for y. So subtract 5. So 5y equals negative 15. And y equals negative 3. So x is 1 and y is negative 3. Okay, so now at the end here I have whether says tell whether the system has one solution, infinitely many solutions, or no solution. All right, so I'm going to, it doesn't really matter. I'm going to multiply the top one by negative 1. Why doesn't it matter? Because if you notice, I multiply by negative 1 for the x, I'm going to eliminate the x. If I multiply it by the y, I'm going to eliminate the y. In this case, this is the top equation. I'm multiplying negative 1 times 9x and negative 1 times positive 5y and negative 1 times 13. Now, bottom one I'm going to leave the same. Now what happens is both x terms and y terms eliminate. If they both eliminate, they're both 0. So 0 plus 0 is 0. On the other side, this is 3. Does 0 equal 3? No, it does not equal 3. So this is no solution. Okay? All right, number 8. This is actually going to be the same thing. I don't know how I got 2 of these. So multiply by negative 1. On the top, that's negative 9x minus 5y equals negative 13. I just multiplied every term by negative 1. Leave the bottom alone. Add them together. This is 0. This is 0. So 0 plus 0 is 0. 0 does not equal 8. So this is no solution. Okay, now let's see which one is infinitely many, what it looks like. All right, so on the top, let's just say I'm going to get rid of the x terms. I'm going to multiply everything by 4 on the top. That way I add the x's together and I'm going to get 0. So that's negative 4x plus 24y equals negative 8. On the bottom, I'm just going to leave it. Some of you are probably already noticing what's going to happen. 0 plus 0, that is 0, equals 0. Yes, 0 does equal 0, so this is infinitely many solutions. And that is the elimination method, my friends.